In this video, we'll be discussing z-tests for proportions. Suppose you're working on developing a social media app, and you receive feedback from a poll that users would like to see a dark mode version of the app to save on battery life and reduce eye strain. From the preliminary poll, you expect about 60% of users to appreciate this dark mode feature. You might pose this question: is the proportion of users who like dark mode higher than expected? Let's define our population proportion P to be the proportion of users who like dark mode. We can define a set of hypotheses, with the null being that this proportion is equal to the hypothesized proportion of 0.6, and the alternative being that it is greater than 0.6. We use a greater than sign here because the question of interest asks us to evaluate whether the proportion is higher than expected. This test is called a one-proportion z-test. In a previous video, we introduced a handy statistical result called the central limit theorem. In particular, if we have at least 10 successes and failures in each group, we can apply it for proportions and conclude that the sampling distribution of the sample proportion will be approximately normal, with a mean equal to the population proportion P and a standard deviation of square root P times 1 minus P over N. We can then construct a test statistic to test our hypotheses for the one proportion z-test. Intuitively, if this test statistic is large, this is indicating a significant difference between the sample proportion and hypothesized proportion. Under the null hypothesis, this test statistic follows a standard normal distribution. From a sample of 1,000 app users, say 630 of them reported to like using dark mode. So, from the formula, we can compute a test statistic of 1.93. Using the standard normal distribution, we get a p-value of 0.0268. Thus, at the 5% significance level, we can reject the null hypothesis and can conclude that the proportion of users who like the dark mode feature is higher than was expected. We can also extend these ideas to compare two population proportions with the two-proportion z-test. For example, is the proportion of users who prefer light mode different than the proportion who prefer dark mode? For our hypotheses, we can test whether two population proportions are equal versus different than, less than, or greater than, depending on the question at hand. The test statistic involves two sample proportions now, with the notable addition of p-hat, the pooled proportion, that is the total number of successes over the total number of observations from both samples. Similarly, assuming we have enough successes and failures in each sample, we can use the standard normal distribution to compute a p-value and make a conclusion in the context of the problem. Now, what if we want to compare more than two groups? Well, it turns out that z-tests for proportions are related to another type of test called chi-square tests, but we'll leave that for another video.